Hello again, everyone. So we're going to start with giving you a few words about our background, and then we quickly cover some of the building science stuff on how we do HERS rating and passive house, etc. And then we are going to cover the new energy code that has been kicking in since January 1st of this year. More is coming July 1st, and more January 1st of next year and July 1st of next year. And in between, we are going to talk about some new technologies, and finally we're going to wrap up with some of the new incentive program from both utility and IRS and etc. So we have been in business for about 14 years now, and we have been covering more than 130,000 cities in Massachusetts and New Hampshire. Bulk of our business is energy consulting and rating and passive house verification, etc. We also do LEED and Energy Star home and passive house projects. Another division of our business does ABS, air barrier sealing, and GCD green construction development. These are some of the people and equipment that we use in the field. We also do 3D rendering and animation work, especially for bigger projects when we zoom in from the bird view going in and showing the future house or building to be built. Sometimes because of in the historical regions, the zoning committee, they ask for physical miniature of the house to be built, or sometimes we have superimposed the 3D rendering that we have done on the street level so they can see what they're going to get. All right, a few words about air sealing. Hopefully we don't do air sealing home like this anymore. One of the newer technology that we do air sealing by is called air barrier. In this process, we basically pressurize the building to 100 Pascal and create a fog inside the building with a totally environmentally friendly material. Is water-based, and it will basically they're using it in hospital, daycare, healthcare, and that fog goes and super air seals the home much even better than a spray foam. And also there are everything is computerized and digital. Let's take a quick look at this video from this old house show, which can basically...
Today in this old house, new technology will stop air infiltration on our entire project.
Just got a head start here.
Now, how long will it take to pressurize and seal it all up?
About 90 minutes.
And we put the finishing touch on a...
So it's even where this existing deck is.
Definitely says mid-century modern.
The money's in the detail.
That is beautiful. Hi there, I'm Kevin O'Connor, and welcome back to this old house here in Jamestown, Rhode Island. This is our bungalow project, and we're taking it from about 1,000 square feet and doubling it to almost 2,000 square feet. And you can see that the framing is complete, and we're pretty far along with the rough plumbing and electrical. Now, our homeowner is trying to get a home that is net zero, and that means that the house will only consume as much energy as it can make. And to get there, we have got to get this house really airtight. Well, Richard has found a new technology that's going to help us do that.
Air infiltration is a constant battle as we try to make a building energy efficient. And even with new construction, there are plenty of places where there are cracks, penetrations, places where air can leave the building, heat that you've paid for, and cold air can come in. Now, historically, we've always chased after it with caulking and weather stripping. But what if there was a way that we could seal every single crack in a building? It would be a game changer. Jordan Kreitz is going to show us this new technology. Now, it's not exactly new technology, is it?
No, this has been around for a little while as far as the concept and the duct systems.
Right, we've used on duct system
Yep.
to seal them up tight.
Yeah, so we use positive pressure basically to put a sealant inside and identify those leaks and seal them with the positive pressure.
So you got your blower door test. How's our existing house? This is new construction.
Sure. We just completed our test and we're at 3.8 ACH 50.
So ACH, that is air changes per hour. How much air would leak out of the building when you're pressurizing it, right? So what's the worst?
Sure. I've seen them as high as in the 20s.
Okay. So 3.87, what's that equivalent to?
That'd be the equivalent to probably this window being open about 5 inches or so.
Under pressure. That's a
Correct.
lot of heat leaving out.
Exactly.
Okay. All right, so what's the prep that you have to do?
Sure. So the prep process will actually tape off the windows so that the sealant doesn't actually seal the windows if they do in fact leak some.
You got to seal every single opening, anything that's going to leave to outside.
Yes, that will eventually be closed off, correct.
Okay.
So Richard, what we're going to do is use this hole where the deadbolt will eventually
Okay.
be to simulate an air leak. And we're going to put this mesh here, and we'll actually be able to see the technology seal this.
Seal right
spot.
up. Okay.
Correct.
Good. We'll come back and check that when we're done.
Here's the basic setup. Here's our blower door.
good. The fan right there, yeah.
So this is what we're going to use to put the positive pressure in. Here's the laptop that essentially is controlling the whole system and telling everybody what to do.
Yeah.
This is a pump system inside of this box here that's going
spray
to
the material in.
Yeah, it's going to pull the material and pump it through the lines to the spray nozzle. And then this is actually the material here.
Oh,
the
there it
sealant.
is, right
Yep.
there. So it looks a little bit like paint in that condition.
Very similar.
All right. You ready to go?
Yeah.
Just got a head start here. Okay, great. Now, how long will it take to pressurize and seal it all up?
About 90 minutes.
Okay, cool. All right, so it's been about an hour. How'd we do?
We are down to 1 ACH 50.
Wow. So we started at what, 3.8, just under 4. Mm-hmm. All right, so that means we can have smaller heating and cooling equipment, right?
Exactly. We can right size the mechanicals to the home.
Perfect. All right, let's go check the door, how we did.
Okay.
All right, so it's almost completely blocked off. That is really cool.
Pretty good.
So you're going to pull that?
Let's get this off there.
Look at that. The bullseye. Sealed up perfect. Mm-hmm. Great. So is there any place where we can see it going through the outside?
Here you go. Right here under the stairs.
So look at that. Between the old boards, it found a crack, even though there's insulation outboard of it. That is amazing.
Yeah.
It finds everything. So what about existing buildings? Do you have to just do new work?
No, this can be used in retrofit applications as well. Just need to protect the finished horizontal surfaces in the space.
And that's probably got as much possibilities as anything. There's a lot of leaky houses out there.
A lot.
All right, so once we get it this tight, there's one more thing we got to think about, right? Getting fresh air into this building, mechanical ventilation.
You got it.
All right, that is really something.
For more of this,
Okay, so as we see, it works. So this is a sample of, the penetrations that they usually don't get sealed, but this computer can find them. And we just recently completed a 180 unit project with Avalon Bay in Brighton, and it was a compartmentalization project, and we brought it down to half of what a passive house requires for compartmentalization, and then guess what? All units, they passed the first time without any problem. Overall, we are on an extension of the project team. We like to get involved in the schematic design phase, and then our objective is basically to help you, build a better home and then reduce your construction costs. And how we do this by helping you try to minimize your heating, cooling, domestic hot water loads by doing better insulation, air sealing, fenestration, windows and doors, and reduce or stop thermal bridgings, and the orientation of the building, shading on the building, all that affects the bottom line. Because we only lose heat by 3 means. So thermodynamics says to us by conduction. That's what the insulation does. Basically, the convection. That's what the air sealing does, and and radiation, which is actually usually more of a problem in the summertime. The HERS rating many of you may know what this is, but the way we do it is a four-phase process. The energy modeling part, the design consultation, midpoint inspection, final inspection, and testing. There's another quick video from BrassNet that might be interested for those of you who are not too familiar with the idea.
Hi, I'm John Bell. I'm here to tell you how to get everything you want in a home. What's on your list of must-haves? Granite countertops? Fine cabinetry? High-end appliances? What about the efficiency of your home? Is that something you're looking for? I'm going to explain why it should be and how your home's efficiency is the key to getting all those must-haves on your list. What makes a home more efficient? Things like renewable energy systems, better mechanical equipment, and a more airtight house. Think of it like the miles per gallon rating of your car. A more efficient home gets more miles to the gallon. But how can you measure efficiency? Introducing the HERS Index, the most comprehensive home energy rating system in North America that has already been used to rate over 1.5 million new homes. Here's how it works. The HERS rating system uses a simple, easy-to-understand index based on a 100-point scale where the lower the score, the higher the performance. Think golf, not football. HERS not only accounts for everything inside the house, but also accounts for everything outside, including what goes up on your roof. So HERS takes into consideration plug loads, actual hot water load, air conditioning, drain water heat recovery, and renewables like solar. And energy savings are directly proportional to HERS point improvements. A 15% improved HERS score equals a 15% energy savings. So the lower your HERS score, the greater the miles per gallon you'll get from your home. And that translates directly into lower energy bills and monthly savings. Remember those granite countertops you've always wanted? Let a HERS rated home help you pay for them. And keep in mind the efficiency rating using the HERS Index ensures predictable performance of both existing and newly built rated homes. And predictable performance is something you just can't guarantee without a rating. HERS is third-party validated, so you've got nothing to worry about. ResNet home energy raters are highly trained, certified, and adhere to the Mortgage Industry National Home Energy Rating Standards. And as an added bonus, certified energy rated homes have higher resale value, resulting in even more cash in your pocket when it's time to sell. Buying a HERS rated home just makes sense. And remember, the lower the score, the better. The HERS score, where less means more.
Okay, and as mentioned, one of the initial processes to create a customized 3D model. We always do that just to extract the data that we need, like volumes, square footages of dormers, etc. Easier, and then we plug it in to this example of one of the energy models that we use. That all the information that goes into the house, it goes to our energy model. And midpoint inspection is the second step or the third step that we do. So our inspectors need to go out there and do midpoint inspection. This is regardless whether the building inspector does his own inspection, we have to do our own. This is a sample of the exterior wall installation. We actually don't like to see spray foam in the exterior walls anymore. And because, a spray foam has its own issues with the gaps and voids and also often air pockets. Now, this was a sample of a good job that we see, but sometimes we see a very bad job because of when they shave off the open cells, they see, you can see air pockets, and that you think you're getting R20 insulation R value into the walls or R21, but effective R value can be going down to R17 or R18 because of those voids and gaps and air pockets. And plus that, sometimes they cause, air leaks as well. Midpoint. So what we like to see is dense packet with cellulose, which is recycled newspaper treated with boron. Or, for example, if you want to get a higher R value, you can use Optima, which is a high density fiberglass. You can get up to like R24 for the for the 2x6s, and or Rockwool, Roxol, etc. Those are all good material. Or just use a high density craft face fiberglass R21 and face staple to the studs. That does a perfect job. Now, having said that, we are not totally still against spray foam. I think the areas like behind the bathtubs or, small cavities less than 6 inches wide, or, if you have California corners or if you have outlets against exterior walls, etc., those areas can be just flashed with foam easier, and that does a better job than craft face fiberglass. Now, this is a picture of one of our inspector took a couple of weeks ago. As you see, a lot of Icynene, and these materials are not really human friendly or health friendly, and it can cause problem. But another thing in this picture is this: look at all these wasted material that has been shaved off, and they are going to last for another 350 million years after everybody else is gone on Earth. So foam fails. If you like more information, you can look into website 475.com. You have to spell it out. They have tons of more information about it. So this is one of the inspection checklists that we use when we go do our midpoint inspection. We call it ABI checklist. So we start with exterior of the building, garage, living space, basement, crawl space, and attic. And as you see, there are many items that we look for. And then either these items, majority of them, the raters does this checklist, but there are some items like a slab edge installation, etc., that we cannot be there, so builder needs to verify it and take photos for us. And everybody at the end, they will sign it off. And usually building department at the end, when they want to issue your CO, they not only they ask for the final certificate, her certificate, they also ask for this copy of this checklist. Final inspection and testing. So again, blower door test, duct blaster testing, and ventilation testing. So this is a ERV as used here. We are going to talk about it more. Final certificates. So this is a sample of a final certificate that we issue. So it has all the information about the house. It has the HERS index. But another thing, it has it also estimates the annual energy cost of this house. And for example, in Massachusetts, we spend about 75% of our energy for heating, but these homes 70 to 75%. But now these homes, we find out that they are just using 20 to 25% for heating. So the stuff that you guys do is going to work. We'll build a better home. The HERS index, I guess they were talking about it in the video, but basically, if this house, for example, is getting a rating of 65, that means that it's 35% more energy efficient than the baseline. The baseline is the home that was built in 2006, new construction. And the lower that you go, the more energy efficient it becomes. Now, before January 1st, Massachusetts was asking for 55. Now we are down to 52. And guess what? Next year, we are going to go down to 42 on the HERS index. And you can go lower and lower and then add some renewable energy like solar or wind. And you can get down to what we call the net zero home, which is essentially you become self-sufficient. You're not buying any energy from outside. And in fact, if you're producing more than what you use, then you can become negative on the HERS index. Now you become a generation, and potentially you can make some money as well. So if you may have heard that, zone 3 and zone 5, etc. We are in zone 5, and what it means basically, the lower the number, the hotter it gets, higher, the colder it gets. Some of the things that we check in the one of the checklists that we use is the TBC thermal bypass checklist. Some of the things we check is, for example, a slab edge installation. And slab edge installation is mandatory anytime you go. So we are in zone 5. It says R10 and then 2 feet below grade. So anytime you have, slab less than 2 feet below grade, you must do slab edge installation. And you can do it from inside or outside. but you need to do a complete job. So like this guy didn't bring it all the way up to the sill plate, but this is the correct way of doing it. This is the wrong way. This is the correct way. Why we are saying we should do this? Because, or the code is saying you should do this, because if the temperature outside is 0 degrees, this dirt is 0 degrees, and this slab is going to be 0 degrees as well, because guess what? The concrete R value is 0. So that's why we need this thermal, what we call the thermal breakup. So, and then walls behind the bathtub. So we used to shove in fiberglass behind the bathtubs or shower stall, but not anymore. It needs to be, you need to have insulation and air barrier in contact. In fact, this is one of the other areas that we recommend to just use open cell, etc. spray foam, because you get insulation and air sealing in one material easy way, and that's not much of an area, so we don't have problem with that. The fireplace is another place that you need to have insulation and air barrier. These days, gas fireplace company, they do a good job. Okay, they use fiberglass, for example, and cover it with thermoply, and use fire-rated caulking or spray foam or fire-rated foam to seal it all up. Excessive framing is another thing we look for. This guy, we're not sure what he is thinking about. So, we know, fiberglass is a lot cheaper than wood, and also it will has this fiberglass has the wood R value is about 1.1 per inch, but the worst installation material you can get these days are like 3.7 per inch and higher. So why spend more money and get less performance? And these these are going to show up easily when we do infrared thermography. And whole house infiltration. So stack effect, basically cold air comes in through the lower part of the house and then warms up, and stack effect takes it out of the house from the top. These are the major sources of air leaks areas. Like, take a look at them. But no, energy code, the stretch code. So as you might know, the Massachusetts put that for adoption back in 2009. Starting 2010, every 6 months, more towns and cities have adopted it. And now we have more than, exactly 300 cities and towns that they have adopted it. We had this is the evolution of stretch code in Massachusetts. So we started with ICC 2009, International Energy Code 2009, 2000, then we jumped up to 2015, 2018. Right now, we are at 2021 ICC, and this is the HERS index of 52. In fact, Massachusetts has committed itself that 1 year after, so these ICCs come out every 3 years, and then Massachusetts has committed itself to make that as a base code every at most, I think 1 year after the code comes out. So again, these are the evolution, and then new stretch code kicked in January 1st. Another one would be July 1st of 2024. And opt-in is specialized code varies, depends on the towns and cities that they have adopted. This is the stretch code map showing all the 300 municipalities in Massachusetts, and then this one same thing, but also is adding now the specialized code, the towns and cities that they have voted on a specialist code and have adopted it. Now we'll get more slides on this. New January 1st, stretch code. Basically, there are 4 things that needs to be done. Well, this is minimum of 4 things. The HERS index of 52 or lower, with some exception, and then but that applies to not only new construction but also renovation, alternation, large addition, etc. as well. And installing ERV, HRV is mandatory. We are going to have more to talk about this. Wiring electric vehicle charging station. So we need to have conduit with this, 50 amp wires through it from electric panel to the future charging station in the garage or wherever. Mandatory. So before January 1st, if all the air handlers in and ductworks were inside the thermal boundary, then we didn't have to test it. But now it's mandatory. Still, we have to do that. And frankly, that's a very good idea because the leakages that we get, like if let's say we have leakages through our return through the chase of the wall, it's going to suck in all this construction debris, etc., or from the places that we don't want to suck in, like basement, where people keep thinner gasoline or whatnot, or from the garage area, which is not healthy. So that's a good idea that I'm glad that they have added this to the code. So basically, Massachusetts says, okay, 2021 ICC comes on that, and then Massachusetts amendment comes on the top of the ICC, and that makes our base code. So even those 51 municipalities that they have not adopted a stretch code, they need still to comply with this part of it. That means, duct leakage testing, etc., still is mandatory. MA stretch code then comes out on the top of the base code, and then a specialized code comes on the top of the stretch code. So when a specialized code comes in, then the stretch code is not going to go away. It's going to just come on the top of that. And we will talk about that. So there are different options and exemptions. I mean, as you see, there are many different basically wordings about a different type of work. Depends on your conditions. Condition of the project, square footages, number of floors, etc. I'm not going to cover all different aspects of it. I mean, afterwards we can have a separate conversation for those of you who have a project with us. Quickly cover your project, but basically in the past we had three options. Before January 1st, we had the HERS rating option, Energy Star option, and Passive House option. But as you see, the trend is that we gradually were moving toward the Passive House option. We'll talk about what Passive House is. But what is specialized code? The specialized code basically is a path to get to our 2050 net zero building. So Massachusetts has committed that by 2030 we are going to get to half of the emission that we produced in 1990, and by 2050 we are going all the way down to zero. So zero emission, and that's why the specialized code came in, and that's why, for example, buildings accounts for nearly 70% of the greenhouse gas emission in Boston. So it's a big contributor, our buildings that we are building. So these are the 4 cities that they have not only voted on a specialized code, adopted it, but also they are enforcing it as early as July 1st. And then more towns like Brookline, Watertown, Somerville, and Cambridge, July 1st enforcement. And then January 1st, Newton, Lexington, Boston, Arlington, Lincoln, Wellesley, etc. I think there are many, many more towns in line, and you will see them we will see when they're going to enforce it. So this basically, as I mentioned, there are many conditions. Like it says, does the project have individual separate dwelling units? Then you follow these codes. If no, then you follow these codes. If is the addition greater than 1,000 square foot, or does it exceed the existing CFA? Then you follow these codes. Otherwise, you follow these codes, etc., etc. So there are many conditions and exemptions, and etc. in the code. So these are just basically the seed idea. So you get a general overview of what we are going to be facing with. Specialized opt-in code, basically, again, it has a different version. Depends on if you go all electric or mixed fuel or zero energy, etc. We'll talk about it more. So here, again, different conditions, different type of code applies, but and passive house, you will see that when it gets above certain size, etc., passive house would be the only option. Basically, a specialized code for multi-family is a passive house. If you're going mid-rise and high-rise over 12,000 square foot, they give you only one option, and that's passive house. For those towns and cities, they have adopted a specialized. So again, a stretch code at the bottom, and then the specialized codes comes on the top of it. And residential low rise, again, different condition, all electric mixed fuel. You have different conditions for a specialized code, which I'm not going to get to it. But basically, if you look at this here, a specialized code, if you're less than 4,000 square foot, then they give you these options. For example, if you're going all electric, then they give you 45 or passive house. But if you're mixed fuel, then you have to go down to 42 or passive house. And if you're between 4,000 and 12,000, then again, they have different condition. But for mixed fuel, now they're asking HERS 0. So you have to install solar is mandatory. But for 12,000 square foot, they give you only one option. Is that FIAS, that's the Passive House Institute US, or Passive House Institute, that's the European version, which basically, essentially, they're the same thing. Passive House, the only thing is since US, we have a lot more climate, different type of zoning. Europe doesn't have it as much, so we kind of came up with our own version of the passive house, but essentially it's the same thing. Now, what is passive house? If you don't know what passive house is, then just remember just one thing, and that's a hairdryer. Yes, and that's the amount of energy that it takes to heat or cool your home at 1,600 watts. And you don't believe it? Let's take a look at it here.
There's one simple hearing hack anyone can use to improve their hearing almost overnight.
Yeah, okay.
Did you know?
And behind me is a new 3,200 square foot luxury home, a passive house. If we've done our job right, we should be able to heat this passive house with a hairdryer. Let's go check it out. This is a large 3,200 square foot home with 10-foot ceilings downstairs, 9-foot ceilings upstairs, and a fully conditioned crawl space. I have a standard off-the-shelf 1,600 watt hairdryer. We're going to place this hairdryer up inside the return air plenum, turn the heater off, but keep the fan on so that the heat from the hairdryer will be circulated throughout the entire home and be the only source of heat. Let's put it up and see how we do. We've strapped the hairdryer up inside the return air plenum, so let's start the test. Okay, we have our hairdryer on. Looks like we're pulling about 1,520 watts or so. Let's go downstairs and check the thermostat for the beginning of our test. We've placed our hairdryer and turned it on. It's 72 degrees inside. It's about 6 o'clock at night. 51 degrees outside and dropping. We'll come back tomorrow morning and see how our hairdryer performed. We're back at the house the next morning. We had a nice cold night for the test. Let's check the temperature. We see about 36 degrees. Let's go inside and see how we did with the hairdryer. Let's check the thermostat. 36 degrees outside, which we tested outside, 70 degrees inside. So we ran the hairdryer all night, very cold night for our climate, and we kept the house at 70 degrees. With advanced building practices like Passive House, we can heat American-sized homes with a hairdryer. See some of our other videos.
Okay, so yeah, it can be done. And in fact, I got a text from one of my friends a few weeks ago, and he was saying, look, Bijan, this guy is saying there was an article. The guy was in Maine and, was saying that he doesn't have a furnace in his home. And I told him, yes, this must be a passive house. So it doesn't matter which weather you go to, but it still can work if you do it correctly. And guess what? Largest passive house in the world. Where is it? Anyone? This is right here in Boston. We are making a 53-story largest passive house in the world, which is going to start this year, 2023. And simple metrics, okay, of idea of passive house. So very low thermal energy demand, heating and cooling. very low total demand, which includes also plug loads and lighting and appliances, and superior airtightness. 5 principles: continuous installation. So you want to have continuous installation around the house. So you stop the thermal bridgings, no thermal bridgings, and then airtight construction, high performance doors and windows, and of course, fresh air with ERV. And this is our pathway to zero carbon buildings. Okay, again, more of a HERS index, different condition, different HERS index requirement if you have solar, non-solar, fossil fuel, etc. Not gonna talk about them. Now, when we do HERS rating, okay, so it's fine, you know, you get to so one of the advantages of HERS rating is that we call the performance path versus prescriptive path, that you can have trade-offs. So for example, if the code says, you know, you need R49 or R60 installation in the roof line or R21 in the, you know, exterior wall, sometimes you cannot do that, that's fine. As long as you do something else better, you know, like better, I don't know, mechanicals or better air sealings or, you know, etc. As long as you get meet these numbers, then you're okay. And however, or maybe less expensive window, but beef up the installation somewhere else, etc. That's all okay. But having said that, there are some items basically that there is no trade-off. Okay, for example, the mandatory air leakage testing or duct leakage testing, or etc. That we will get to in some of these mandatory requirements. So mandatory blower door test. So what is ACH? If you have, that's air change per hour. And then basically we measure, when we do blower door, we measure everything in cubic feet per minute at 50 Pascal. We multiply it by 60 minutes divided by the volume of the whole house. When we say 3 ACH 50, that means 3 times the air volume of the house is exchanging with outside at 50 Pascal in 1 hour. Okay. So when this one is 5 times the air volume of the house. So the tighter, the better. That's our goal, is to get it as tight as possible. Duct leakage, 4 CFM per 100 square foot is a mandatory requirement. So we call it 4%. Mandatory ERV, as I mentioned, is mandatory. So what is ERV? Basically, an old warm air is coming out of the house through this box. A cold fresh air is going into the house through this box. In this box, they're going to exchange their heat. So very efficiently, instead of using gas or electric, heater to warm the cold fresh air, then we just this guy gets his energy from the warm air that's going out. And it can do it very efficiently and effectively, 85% plus efficiency can be obtained. And then we are in zone 5, so we always recommend energy recovery ventilator versus heat recovery ventilator, because ERV also can, handle moisture. There are different type of versions of the ERV, so you can, this is a compact version which uses ceramic and alternating fans, etc. In some of the emails that we send you, for those of you who are clients, then there are links to these new technologies. Mandatory ERV, so we talked about it, I think, and then, this is a mandatory EV ready and also mandatory PV ready that has been code for the past, since 2018, ICC kicked in. And then basically for PV and EV ready, you need to reserve a spot for future electric panel with a 240 breaker reserved for future install. And then the solar PV ready says basically that you need to reserve a spot on your roof, basically free of the vent and chimneys, etc. Has to have a certain width, 5 feet, etc. And then it has to be, between 110 degrees through north and 270 degrees. And this is a sample of a project that we did for one client. This is the shading areas, the areas that are suitable for future solar. And also remember, you need to put your roof live load and dead load on the planes as well. So mandatory piping is another mandatory requirement. So anytime you have 100 water between well over 105 degrees or less than 55 degrees, you need to have those foam insulation R3 foam insulation on the pipes. Also, at the end, when we send you the final HERS certificate, second page is going to have the sticker that needs to be installed on in the electric panel or somewhere nearby. That's a mandatory requirement. Exterior lighting. So again, why these lights should be on, during the daytime. So it's mandating that you have some type of automated mechanism. It's a very good idea. I have installed it on my existing home, also in my basement and attic, because those areas, if my kids, for example, they go to the basement, don't turn the light off, it can be on for a couple of weeks without anybody else going there. So an attic is the same situation. So it's a good idea to do. Now, as you may have heard, we are pushing for all fossil fuel free, all electric. But one of the drawbacks that we get when we talk to our builders, etc., they said, no, Bijan, we have to have gas stove. There's no way, gas stove. My buyers, they want gas stove. Now I question why. Because we have new technologies. Why we should stick with gas stove? Induction cooking, what it is, it is basically uses electromagnetic concept basically to it's not going to heat up the stove, but rather the pot is going to the only area that gets hot. And why is better? Because it's 3 times it can faster can boil the water than gas stove. Much more precise cooking, much safer cooking, because this doesn't get hot at all when you have children around. 3 times more efficient than gas stove. And of course, it's not going to produce any of those gas stove methane, NOx, CH2, you name it. All these combust. And that's, in fact, the fact that your builder, your building inspector is when you see a gas stove, they usually they ask you to put a 400 CFM plus, kitchen exhaust hood, and that of course kicks in the mandatory requirement to have a makeup air. So you can avoid all those, requirements. Then of course much easier to clean because there's nothing that's going to be burned on the stove. But let's take a quick look at this video here if you want to see it for yourself what it is. Oops, sorry.
Induction is very different to gas and electric. It's a completely different experience and technology. Inside the stove plate, you've got an electromagnet that actually spins around and turns the pan into the elements.
Okay, so another thing that I hear from my builders, oh, they have to have gas stove or wood fireplace, etc. Guess what? These are not gas nor wood. Okay, and so the technology is there. Check them out, please. Heat pumps. So we have mini splits, heat pump, ducted, ductless, air source heat pump, ducted, ground source heat pump, geothermal, etc. And then air to water heat pump. And this is actually one of our favorite ones these days. And why? Because it can do 4 things in one, basically one equipment, one condensers that usually is narrower and taller. You put that outside of the building. It does heating, cooling, domestic hot water, and radiant floor heating. So basically, one pipe comes out to your air handler inside and provides a force out air, the cooling, and then it comes usually with a super insulated tank that you put it inside the basement or somewhere. And then if you want to do radiant floor heating for kitchen or bathrooms, etc., it can do that as well. 90% less emission, 80% less energy, and 40% lower utility bills. This is a graph, and it basically shows you this is geothermal. Of course, when you go below 4 feet, always the earth is 55 degrees, so that takes advantage of that. But in the cold temperature, the efficiency of the air-to-water heat pump or air source heat pump comes down. But guess what? I mean, I hear sometimes also from builders, oh, this heat pump is not going to work in the cold temperature. No, it is going. That was in the past. Okay, the new technologies, as you see, they work in minus 13 degrees even. Just the efficiency comes down. But usually also all of these, they have pure resistive electric backup. Basically, it kicks into the auxiliary mode. If we get that low, but guess what? Thanks to the global warming, we are in Boston. We are how many days of the year we are experiencing this cold temperature? Incentives. Okay, last part. So right now, if you are doing an RNA renovation and addition, 3 stories or less, we can help you get up to $20K per unit. That is, I think it's very generous and incredible from utility program. So if you're doing for example, 100-unit renovation project, 3-story or less, we can get you up to $2 million. That's something. So, and also 0% interest loan up to $50K if you're doing single or smaller multifamily units. Residential new construction up to $10K. That's like the past before has been. All electric, if you're going all electric level 1, they pay you for single family, for example. We can get you 15 grand or 25 grand level 2. This one requires the rigid installation, etc. You can ask about this. There are some other thresholds, etc. With it. Mid-highs rise up. They have their own passive house incentives. Right now, we can do, I don't know how long this is going to last, but as of now, we can do it almost for free. It's not totally free, but feasibility study and initial energy modeling, we can do for you, so you can do some cost-benefit analysis. And usually what we have found out for mid-rise and high-rise, which essentially there are boxes, it's less than probably 2%, or maybe sometimes there's a wash there. And additional $3,000 per unit if you go all the way for certification. Because of IRA Act last year, IRS now is offering, if you're going for Energy Star, they give you $2,500. If you're going with a zero energy ready home from DOE, they give you $5,000. And for multifamily, these amounts are reduced, but if you're having a prevailing wages project, then they offer you $2,500 or $5,000 per unit. Okay, why we are doing this, all this? Because of healthier home, ventilation, air quality, water quality, thermal health, lighting and views, moisture, noise, and safety and security and dust and pests are some of the things that we care about. And why we are doing this? Because of comfort, safety, health, air quality, sustainability of the building, reducing your utility bills, and resale value. And guess what? These younger generation, they do care about these things, and they look into it. And of course, by the way, helping the environment. So now I am open to any questions.